All right, welcome to statistics. We're going to be looking at probability. Now, I know I said welcome to statistics, and the first thing I say we're going to talk about probability is because an embedded aspect of statistics and the discussions that we need to have inside statistics center around a proper and complete understanding of probability. Now, in a previous video, I talked about the basics of probability and the idea of randomness occurring. We need to continue that discussion and talk a little bit more about events that take place inside of particular probability situations. Namely, let's say that we have two events occurring. Okay, so let's say we have event A and event B. These can come in two situations, disjoint, and I know as odd as it may seem, non-disjoint. So why don't we just say disjointed, right? Well, the actual terminology is a little different than what we would necessarily think in terms of. But let's have a discussion about what it means for it to be disjoint. Disjoint means that we have event A and event B, and they have no overlap between them. So there's no possibility, or there's no situations where those two events coexist. There's no situations where something that exists in event A also exists in event B. For instance, let's say that we take two dice, and we roll those two dice, and we want to know what is the likelihood of rolling a sum of 3 or a sum of, let me back up, rolling a 5 or rolling a 6. Let's do it that way. Event A is rolling a 5, event B is rolling a 6. Are there times when those two events coexist? Yes, we can roll a 5 and a 6 at the same time, which means that would be a situation where we'd have this happen. We have an intersection between those two events. So over here on the right, where I have these two Venn diagrams. I have this one which is disjointed, and this one is demonstrating a jointed or non-disjointed situation. What means we have the situation that occurs right here in between these two things where we have this overlap. That changes the way we do the calculations for the probabilities. If these two events are simply disjointed, we just find the probability of each individual event and add them together. If there's no overlap between those two events, then that's pretty straightforward what we do there. However, if there is overlap, if we have a situation where it's non-disjoint, we have to take out the situations or the overlap between those, because we would count all the probabilities for event A, and then we count all the probabilities for event B, but that little section, that overlap, has been counted twice. So we have to subtract off what's called that intersection between A and B. Okay, so we'd add the two probabilities together, and then we'd subtract off their interaction. And that's what this piece is right here, this is their interaction here. Now, this is all under the assumption that all these events are what we call independent. Independent is removed from disjoint. Disjoint is talking about the overlap that exists between two events. Independent is talking about whether one event is dependent upon another one to occur. For instance, if we're talking about a deck of cards, those are not independent events, although we could have events that are disjointed. When we're talking about rolling dice, those events are independent and they are also disjointed. Okay, so once again, when we spread this out, so we have a deck of cards. We pulled two cards. The second card is going to be dependent upon what we pulled the first card out as. That makes that an independent event. But depending on what we're concerned with event A and event B, those could still be disjointed events. If you're talking about rolling dice, we can roll dice, and those are independent events regardless. And they could be disjoint or non-disjoint. So we have to be clear about when we're talking about our events and the situation. These are two different aspects of the probability. Independent versus dependent, and disjoint versus non-disjoint. Is there interaction between the events? And is one event dependent upon the other to occur? So those are two different things to pay attention to when you're dealing with these situations. So now let's look at another aspect of this. So the first one is when they are disjointed, and this is when they are non-disjointed. Okay, this is what the situation right here goes. So let's talk about a disjoint and non-disjoint, but we're also going to talk about independent events as well. So what I have here is rolling two dice. If we were to roll two dice, those two dice would be independent of each other. Okay, and we'd end up with this set of permutations here. Now notice there are 36 of them. We could roll the first dice, and if you want to assign colors, we have a blue dice and a purple dice. We roll them. When the blue dice can come up as a 1, 2, 3, 4, 5, or 6. The purple dice can come up as a 1, 2, 3, 4, 5, or 6. So we then have to keep track of all the permutations from those. Now the idea about the permutations is I'm kind of pointing out that the order in which these come up kind of matters from the perspective of that we have two different dice to keep track of. So the event of 5, 6, down here looking at the bottom right of this, the event of 5, 6, and 6, 5 are two different occurrences of a sum of 11. So those are two different situations that give us the exact same sum. So if I wanted the probability, okay, if I want the probability of my sum equaling 15, that'd be event A, not 15, I'm sorry. My sum equaling 11, that would be 2 out of 36, right? So what if I want the probability of my sum equaling, say, 4, right? Well, how many different ways can I get 4? Well, let's look at the table over here that we created. I can get 4 with a 1 and a 3, a 2, a 2, and a 3 and a 1. So that's 3 different ways I can get 4. So what's the probability of getting a sum of 11 or a sum of 4? So that would be 2 over 36 plus 3 over 36, which gives us 5 over 36. Because those events are disjointed. There's no overlap between those two situations. Now, what if I want the probability of rolling, say, a 5? How many different ways can I roll a 5? So let's go over here and we count all the ways we can roll a 5. So this column right here has 6 different instances of 5. In this row, we have that row right there, the fifth one. So we have the fifth column and the fifth row, and we have 6 different ways we can roll 5 that way. So it gives us a total of 12 different ways that we can get a 5. So what's the probability that we could roll a 5 or get a sum of 11? Now, we can go ahead and say, well, we know that's 12 over 36 plus the original sum one that we did up here, which was 2 out of 36. Now these aren't disjoint. If you pay attention, you get 5 over 6 occurs, or pardon me, 5, 6, and 6, 5 occurs twice. So there's a situation where both of these things do actually occur. So the thing that we want to pay attention to is we can also have to figure out what's the probability of doing both of these, of rolling a 5 and a sum of 11. What's that probability? In which case, it is the probability of A, which is rolling a 5, right? So let's just call this one A, and then call this one B, right? So the probability of A, what's the probability of A? Rolling a 5. We can do that 12 ways. So 12 out of 36, all right? Then we're going to multiply by the probability of B, right? Probability of B, that was getting a sum of 11, which was 2 out of 36, which gives us 24. So we got to subtract off 24 divided by 36 squared. Now, I won't do that multiplication in my head, but that's what we'd have to do to figure that out. So we need to subtract that off. Now, another way, since we actually have what we're looking at in front of us here, we could actually count this out. But this would be the actual process we'd go through, because these two events, rolling the dice, are independent, but the events that we're concerned with occurring here are not disjoint. So keep in mind, the events can be independent and be non-disjoint, just like I do in this situation, meaning that there is some overlap in the outcomes. Independence is referring to the actual event itself. Is it dependent upon, is that an event dependent upon another event occurring? Is something else going to affect its outcome? Like if you pull out a 2 out of a deck of cards and you want to know about pulling the next card. Well, regardless of what you pull out as the next card, you have changed the situation. You now have 51 cards and you have one fewer 2s. So that is going to change every probability for anything else that's pulled out of the deck of cards. So those are non-independent events. But we could have a situation where those events are disjoint because there's no overlap. So what's the probability of pulling a 2 or a 3? There's no overlap between those two events, so they are disjoint. But they are dependent events, which means we'd have to do this situation or figure out these formulas a little bit differently. So that's the idea behind disjoint and independence. And those are the two formulas. And if I can just go back up there and kind of rehash this real quick for you, you have the two different formulas for finding probability when you're talking about an or between two events. And it's, if they're disjoint, it's just adding the two probabilities together. If they are non-disjoint, you add the probabilities together and subtract off their interaction, which just simply means multiply A times multiply the probability of B. I hope this is useful. Hope this was helpful. If you have additional questions or comments or need additional explanation, please reach out and let me know. Otherwise, have a great day. Take care.